Hello, and welcome to this presentation entitled Conceptualizing Game Environments as a New Medium for Procedurally Interactive Computer Music by myself, Stephen Lewis. And before we get started here, additional demos can be found at the website provided below at www.smlewisportfolio.com. There will be a number of brief demos given throughout this presentation, but full-length audio-visual performances, as well as standalone audio samples, max patching, and Unity programming and game design can all be found at that website's provided. All right, so let's get started. What is procedural sound design? According to Andy Farnell, procedural sound design is the generative, real-time creation of sound from scratch through an object-oriented process, rather than modifying pre-existing audio data, which is known as an audio file. So this combines the physical modeling, as well as the way in which we psychologically perceive sound, and the mathematical implementation of both the physical and psychological aspects to create living sound forms, where sound is an object with attributed movements and dimensions. This is done by observing an object's behavior, modeling that behavior sonically, and then mathematically implementing that model into a given game environment. Now, this is a highly iterative process and basically generates sound from that generative process. This can also be thought of as an algorithmic composition or another form or practice of algorithmic composition. And that is the crux of this thesis presentation, where we are going to leverage techniques and concepts found in procedural sound design, traditions of live performance, and by studying the behaviors within computer music models to create a procedurally interactive medium for computer music, where objects can procedurally shape sounds and alter parameters based on their own morphology in real-time action. Meaning, we want to translate virtual player gestures into musically meaningful results. The immediate goal here is to reconceptualize the interactive nature of video games and its relationship to music. And it's basically a form of role reversal, where instead of music always being made in service of the game, we are creating a game environment in service of the music. Essentially what this means is that the game environment is your score. Now what this does is it will derive new methods for the creation of mine or anyone else's visual art practices. And this also helps in constructing an interactive environment for experimenting with different sound practices by combining different behavioral models of computer-human improvisation within one large structure, as we'll cover. This is also in the pursuit of developing a prototype which could be modeled and expanded upon for future performances. Speaking of the broader long-term goals, this prototype is meant to serve as a working model for further experimentation into augmented reality. If we can get this into augmented reality, we have the creation of large-scale public artworks. And we could start broadening the cultural definition of what constitutes a musical performance by translating physical activities into musically relevant gestures. What this will do is establish a new environment for a more inclusive music-making process, where hours and hours of studying a very difficult acoustic instrument is not necessary in order to be a part of the music-making process. Now, constructing the system had to do with combining technical skills and also considering the conceptual aspect of what I wanted the Unity environment to be. Now, the consideration for this project, first of all, had the success of it would be gauged based upon the subjective aesthetic quality of the visual and audio output. The success would also be gauged on the usability of the environment. Was this just something that I could use, or was this going to be something that other people could use in the creation of their own audio reactive visual art? That was very important to me. And both of these had to do with the third ultimate consideration, which is the role of the Unity environment itself, which, as I just said, really was an experiment into the role reversal. How was the game environment going to be this scorekeeper? How was it going to act as this improvisatory environment for the virtual player? And what was decided is that I was going to convert a pre-existing algorithmic source where there's MIDI or algorithmic patch, where there was MIDI being used as a control source, which would affect audio processing, as well as the processing of the live performance, in this case, a drum performance, and how I would measure via max listening objects. I would measure the audio processing and the live performance parts of the patch in order to drive the visual aspects. So instead of using those visual processing and performance patches to drive the visual output, what I wanted to do was to control the visual output from the listening objects that would be procedurally tracking the procedural audio patches that would also be controlled by player movement. And that's really where the player movement came into consideration. The virtual player within this game environment was key because their behavior would ultimately be translated into control data. The environment was the virtual player's instrument. The movements they made in this instrument or on this instrument would be related to gestures or related to gestures. Those gestures would be thought of as musical motions. The game environment and the programming would manage the range of musical motions and send them to max, and the continual player movement would be thought of as streams of data. An example of this streams could be thought of as LFOs for further parameter processing. So the MIDI notes or the control source, as I'm thinking about it, are sent to the audio processing, and the audio, that MIDI is controlling basically the random selection of certain audio playback, and so there are a number of things going on here. But mainly, you have three different audio files that are being played. You have an individual sample that is a field recording of something that I've taken and already manipulated max offline. You also have the capability of loading a file of any number of samples. I think this one's pretty sizable. Yeah, I think there's about 190 in there. And they will be randomly selected and updated based on that MIDI information. These audio files go to the comb filter here, and the pitch of the comb filter, as well as a lot of the other filter specifications, are being dynamically updated by that MIDI information as well, or those MIDI updates. The same can be said for this algorithmic delay. The next step in this audio processing chain goes from the audio here, the comb filter, to the algorithmic delay. All of that then goes to this source blender, which is panning these sounds in quad. So while that's happening, the MIDI is also being used to update based on the delta times these two generative synths. The parameters of these are actually being randomly modified, with the exception of the level here. And these signals are routed to the quad panner as well. And so we have 1, 2, 3, 4 sources being routed to this quad panner. If we were to play, each channel is designated one specific source, and that is being dynamically changed either through an LFO here manually on the pick slider, or through a MIDI device, or as we'll see in other videos, through player transforms in the game relative to the game area or game positional data. So that is one audio signal chain. We then have multi-channel audio. We have multi-channel drones here. The LFOs, or the rate of changing here, is determined by MIDI. And then we have a vocal part, which is controlled, the multi-speed sampler, basically like a granular, it kind of gives off a granular synthesis effect of this audio here, is controlled through MIDI as well, and this is the same delay in multi-channel as this algorithmic delay here. These are routed. These four are components are routed to this multi-source blender, and then they're sent to in quad to the DAC as well. So that's one part of the audio components, and then you have the actual simulation of the live components of the piece, which is the drum performance, which is basically taking the FFTs and convolving a convolution of a processed drum sound with the original drum sound. And this here is actually, the filter here is actually being controlled by the same MIDI pitches that are being generated in real time. So while by the previous MIDI patches. So while you don't actually hear those MIDI notes, the filter sends here are the same exact pitches that you'd hear in those MIDI notes. So you have three different signals here. You have your processed, well, you have four different ones. You have the original signal, you have the processed drums, you have the convolution of those two, and then you have the filtered original drums plus the convolution of these two sources, and these are blended together here. Those four sources are then sent to the quad panner as well, and those are then sent to the DAC. And so you have about 12 different audio sources, each being sent, so basically 3 different samples per channel on each panner, and it balances quite nicely, and it provides a pretty interesting generative effect that is different every single time you hit play on this project here. Now, what this meant is that we now had a live performance, a live performer, and a virtual player sort of playing at once. And what this is reminiscent of is the free jazz performance model that Todd Winkler covers in his book, Composing Interactive Music, Techniques and Ideas Using Max, where neither the performer nor the computer user is in complete control. And this results in 2 distinct improvisatory decision-making processes within the overall outputs of the system. And this is demonstrated here in my system pretty evidently. Now, we have 2 different layers of interactivity happening here. We have the Unity game engine, and we have the live performing instrumentalists. Both are sending information into the Max Hub, which acts as basically the central processing site for all control source data. It also facilitates data exchange between the virtual player and every other component in the live, in the patch. It also handles initial video processing, audio processing, and all of the procedural audio models. Now, within this free jazz performance model, you can see that neither the performer nor the computer user is in complete control of the total output of the system. And each one, furthermore, influences the decisions that the other will be making. What this is reminiscent of is the player paradigm. So we have a behavior within the larger free jazz performance model. And the player paradigm by Rowe says that it provides an equal amount of compositional influence to the human and machine components within a real-time performance. This could be seen in Rowe's composition Maritime, where Mari Kimura performs, where the violin seems to be the processing of the violin seems to be like a natural extension to the physical instrument that they are playing. In addition to this, I wanted the live performing instrumentalists' role in this environment to be as easy as sitting down and playing. And by naturally sitting down and playing the way in which they would do in any other context, there would be a generative output that would be related to what they played, but also independent. And what this generally means is that there would be a symbiotic shared control of a musical process where the instrument's generation of ideas and the performer's musical judgment would work together to shape the overall output of the music. Now, in addition to this, we also have procedural synthesis. Now, this procedural synthesis here, it's important to realize that this is happening within the Max Hub. This is just done for visual purposes. And you are basically getting, where the system is reading player positional data into the procedural assets. That player positional data and other control source data is used to essentially create sound from scratch. That sound is then listened to with max listening objects, scaled, and then used as a control source for jitter visuals. Those jitter visuals are then placed back into the Unity game engine. So theoretically, there would be, for any sort of musical gesture inside the game environment, there would be a requisite visual response. So what this does is it allows a multi-tier kind of behavioral system to exist within the free jazz performance model, where we have attributes of the player paradigm, generative influence, and procedural audio all working together to create and to conceptualize this new medium. Now, what this means is that there is a systemic interdependency between all of these behaviors, where the consequence of affecting or changing one part of this system would affect all other parts of the system. Therefore, there would be one change to, say, the Unity game engine would ultimately change the visual output and the quadraphonic panning, because everything is interconnected. The sonic and visual outputs should be interconnected and interdependent of all system parameters. All right, well, this is the primary interface that the user will be interacting with or monitoring while the game environment and the max patch are working in tandem. Now, as you just saw that player demo or the Unity demo featuring the virtual player, the graphic that kind of flashed on the screen was this max beat patcher here, which actually tracks all Unity OSC Open Sound Control data coming from either Unity to Max or the opposites, coming from Max and sending it to Unity. Now, this is going to track the player and the three enemies' respective world positions. Those positions then get scaled to any meaningful number, but we're actually using, or I'm using, a number 0 to 1. And then I scale that number again from 0 to 1 to a meaningful number, depending on where I'm eventually routing that data. This second part, audio measurements, actually measures the amplitude envelope and the spectral centroid of each of these 4 tracks here that are being randomly selected via one of these polybuffers. I believe the polybuffer that's being used right now has 304 tracks in it. So every time I hit the lowercase f key, which is coincidentally the same key as that allows the virtual player to fly in Unity, or to land, to stop flying in Unity. Each time I press that button or the player decides to do that, these random audio files will be selected once again. So anyway, those measurements are sent back into Unity from 0 to 1, and then they're actually scaled in the opposite fashion than the player and enemy transforms, and they are used to actually move certain cubes and certain shapes within the Unity environment that the player is trying to capture or to run into in order to complete the game. Now those cubes here, pick up 1, 2, 3, and 4, have their own world positions, and they are also being scaled in a similar fashion that the player and the enemies are being scaled. So if we just go into this beat patcher here, you'll notice that in order to receive incoming data via OSC from Unity, you have to use a UDP receive, specify the ports and the messaging. You can then unjoin those 3 world positions. So we have an X, Y, Z transform elements. Those can be scaled down to 0 to 1. And now we actually have 12 different LFOs that can be used to control any sort of parameter processing that we want. The same can be said for the pickup transforms as well. All right, now while the virtual player and the instrumentalists are performing, the operator of the system, which could be one of the performers or a third person, would be interacting and monitoring this interface primarily. In addition to all the other interfaces shown in this presentation regarding like audio processing and the visual processing interfaces. This is actually the interface that the operator will use to monitor the routing of all this OSC data. As you can see, there's not a whole lot of effects that are visible without actually clicking on all of these different beat patchers. Like these are all different, essentially encapsulations of different interfaces that lead to effects processing. But what this reveals is basically data flow from Unity to Max and the ways in which that can be monitored in real time. And for instance, just to give a brief example, one of the ways in which the Unity and OSC tracking data from the world position scaled down to 0 to 1, or I think I also use it from -1 to 1 in certain cases, can be utilized is through time stretching, pitch shifting, and filter automation. And not only that, but I can, in real time during a performance, be able to change the individual routing for different audio files uh, from the Unity game world, or maybe from the motion tracking. Or I could also set it to default values that are automatically set when you open up the main interface here. So the way in which the operator would do this in real time is to simply just turn on time stretching. I can turn on pitch shifting, and I can um, automate a filter, right? And now I have a choice between two different options. I can either stay with my motion tracking, which would be represented by all the different frame differencing values, and this box, and this slide, and these sliders here as well. Or I can reroute that data into the scaled player X. Excuse me, that is the player X transform value that's coming in from the OSC. I can do the same. I can do the same thing for enemy 1. I can do the same thing for enemy 2 and enemy 3 as well. And so these are all theoretically continuously changing continuously changing values, and Unity, and especially the enemy transform position values. And I can be using those to change the rate of time stretching, pitch shifting, and filter selection. Not filter selection, but filter value selection at a consistent rate. Um, there's also ways that you can individually change this routing for each track, and I can also automate every parameter, and I can also automate all of them to Unity. So if I wanted to switch every single routing from the motion tracking here to the values coming in from Unity, I can do that with just two simple clicks of a button, which is very important to be able to have, albeit a very detailed interface, and you must know what's going on, I suppose, in every single parts of the module here. But after you learn that, it's just a matter of hitting two buttons, because theoretically, and not even theoretically, but for practicality's sake, the individual operating this interface is the same individual, one of the individuals most likely performing in real time as well. Right, so in addition to the ways in which the player transforms and the enemy transforms affect the pitch shifting, time stretching, and filtering of these 4 audio files, they also affect the automation of the quadraphonic panning that basically will control the spread of these 4 audio files. And this is automated here, this pick slider, by the X and Z enemy 1 and enemy 2 transforms, which are always moving at a specific rates, or perhaps even faster if the virtual player comes in contact with them or within close proximity of them. But thankfully, these enemies are always moving, so it allows us to basically get a continuous stream of data happening at a fairly consistent rates, so that we can pan, and we can alter certain audio effects smoothly. And so other ways in which I try to use this positional data to affect the audio output is to not only automate the panning of these audio files, but the speed of the player actually gates certain audio parameters and audio files from playing. For example, the procedural audio effects up in this beat patcher are gated to be turned on when the player reaches a certain speed and they're running or in they're flying. As you can see here, when the player reaches a specific speed, or when the user decides to, instead of using the player's speed, correlate this to whatever pitch up here they choose. The procedural audio sounds will be gated, and the opposite will happen if that threshold is not met. Now, if that threshold is met, it also allows these 4 buffers to play, which are actually recording the drum performance in real time, and then manipulating it in certain ways through essentially the same techniques here with time stretching and pitch shifting after the fact. So I can either affect the panning and the playing of these audio files via the mouse state here. If I click on mouse states, you can see that depending on where my mouse is in relation to the screen, one of these specific audio buffers will play. Now, I basically divided the screen here up into 4 quadrants, and I decided that I would do the same thing for the Unity environment. So I went into Unity and divided the game area into 4 different quadrants, and decided to automate these 4 audio buffers, or the triggering of these 4 audio buffers, either by this pick slider here, which is the X and Z transforms, or by the X and Z player position. So we can get some variety there. So essentially, I believe that my screen here is 1440 by 900. So if I just divide those 2 dimensions in half, if I'm over in this quadrant, as you can see here by the math, this buffer will play, this buffer will play, this buffer will play, this buffer will play, and the math sort of bears that out. I'm doing exactly the same thing in the Unity environment, and just the way in which I would switch between inputs of data streams, I'm doing the same thing here. I can either choose to automate this, and then after I automate it, I can either stick with the enemy positions, or I can click with the to automate via the X and Z player position here. Now, evaluating this system. Evaluating this system, it was decided, would be done through a qualitative analysis based on the deduction that as just demonstrated, or procedural sound synthesis is another form of algorithmic composition, where interactive computer music and the free jazz performance model is premised by the interdependent components procedurally communicating with each other. And as the result of that, more layers of this procedural communication would net autonomous behavior, which could translate into procedural control sourcing, which would then net a more immersive, interactive environment featuring closely correlated audiovisual outputs. So the basis of these evaluations would sort of be based upon the original considerations of the system. I was going to evaluate based on the subjective aesthetic quality of the output. Once again, the system's usability. And lastly, the role of the Unity environment. How was the perception of this interactivity in the system gauged? Could users other than me discern all the different layers of interactivity and how each one kind of affected the net outcome of the system? The evaluation criteria here. How were the human and visual performers sonically linked? Mapping strategies in the game needed to be easily perceived and easily be correlated to specific audio processes. Was the reactivity of the video closely linked to the sonic interactivity of these audio processes? Was there a direct correlation between the process visuals and the gameplay choices being made by the virtual player? And was the procedural audio being used as an obvious audio control source for visual processing throughout the system? This was done through an expert panel where Adam Roxar, Daphne Naftali, and Morton Subotnick were all hand-selected as evaluators of this system. And they were picked on the criteria of their expertise. Adam Roxar specializes in interactive visualization systems. Daphne Naftali was selected based upon her expertise in programming Max architecture and creating user experiences within Max. And Morton Subotnick was utilized for an overall aesthetic critique of the system, as well as whether he could perceive all the layers of interactivity happening at once. Now, the primary feedback of the system was as following. The more mapping options at a user's disposal meant that there needed to be an increased demand on the automation of the systemic parameters, specifically relating to the visualizer. Video effects, as Adam put it, had to be completely automated. There were simply not enough hands for the interactive system to visualize unless all of these parameters were automated. Secondly, the programming needed to reflect a system that enabled and not disabled others to use. This meant that we had to incorporate an advanced preset management system. With an advanced preset management system, it meant that the interface could be simplified with less options, which led to a more cohesive, better way of organizing the project thoroughly. However, it's important to realize that with a better advanced preset management system, users felt less intimidated by the vast architecture in this system. Thirdly, the visual and audio events needed to be tightly synced. Specifically, specific and obvious relationships for parameter mapping needed to be established. And as Morton Subotnick put it, when there was complexity in both audio and visual, things are moving so fast that all you have is complexity and not much else. The audience doesn't know what to pay attention to, the music, the system, or the video. In conclusion, based upon the evaluation criteria and the feedback that I got, human and virtual performer actions were definitely sonically linked. When a virtual performer made a decision, it was definitely mapped properly within the rest of the Max hub, and the user could hear that interconnectivity. Mapping strategies in the game could easily be perceived to specific audio processing therein. However, the reactivity of video was not closely linked to the sonic interactivity of those audio processes. There was very little direct correlation between the process visuals and gameplay choices, and procedural audio was not an obvious control source for video processing or for visualizing additional audio processing. And what this meant is that I had a very effective tool that made artistically satisfying results, but did not behave exactly as I predicted. This may have been as the result of procedural audio not necessarily being heard, but as a control source for visual processing. Now, further conclusions. There is a need for extremely correlated audio-visual reactivity. The system needed to be constructed and mapped to allow for a more seamless integration of audio-visual elements within the game scene. Harkening back to that comment about procedural audio just now, the procedural audio probably needs to be heard explicitly for it to be used as a way to procedurally track and change the visuals in real time. Now, the example of this could be Tunity, which was made by Gay Wang in 2018, which incorporated Chuck and Unity together for a tightly controlled audiovisual experience. Chuck being an audiovisual programming language that allows you to make modifications to procedural audio programming in real time. Now, simplifying the audio and visual source material will more easily show the direct mapping relationships between the two. Source material may have, and Morton Subotnick's quote indicates, may have been a little too complex. And lastly, the perceived success of the system's procedural features, no matter how well designed or programmed, will be determined by the way in which humans in the virtual player perform. This is due to the interdependency of the system, but also due to the nature of performance in general. A performer, especially in an improvisational context, will make decisions that will ultimately affect the way in which the other musicians or virtual player in this context will interpret and then proceed to create music based upon preceding decisions. Future work and broader considerations have to do with scaling this for large performance systems in virtual reality, where immersive is not limited to games, but can be for augmented virtual reality, sound installations, art installations, museums, and musical performances. Now, furthermore, what this means is that this technology can be broadened and to include a more inclusive process of cross-cultural and social art making, where we can think of music as being, as I previously said, a direct causality of gestural motion rather than intense discipline and instrumental practice. What this will do is make a more inclusive music-making process for a large-scale performance systems in augmented reality. These are my references included in this presentation. Thank you very much.